Hey guys, today we are going to go in the opposite direction of what we did the other day. So the other day we were graphing sine graphs or sine functions. Today we're going to look at a graph and we're going to determine what that function would be that would create that graph. Okay? So for example, first thing we're going to do, we're going to look at this shape right here. And the first thing we want to determine is what kind of function is it? Well, notice that this graph goes through the origin, and then it goes up from there and down. This is a sine graph, okay? Cosine graphs start at their high point. Sine graph starts in the middle and then goes up from there. Vertical shift. This graph starts right here. It goes up to 4 and it goes down to -4. So there is no vertical shift. So that's going to help us. What is the amplitude? All right, well, again, if we start here and we go up to 4, that means that's what our amplitude is, okay? So remember what we're trying to figure out. We're trying to figure out y equals a sine of x and plus h. Okay, so we're trying to figure out this information and how it's going to go into here. And that should have a k in front of the x. Sorry. Okay, don't want to forget the period, which is the next thing they're going to ask us here. Okay, so what we're doing is we're just trying to figure out the blanks to fill in here. What numbers to throw in, okay? That is going to create this shape. So the period. Now, period is the width of a cycle. So if this is where my graph is starting, think of what a sine graph does. It goes up, it goes down, and then it comes back up to where you started. This is the end of the cycle, okay? They've drawn extra graph here. We don't need that. We just need to know where it starts and where it ends. This is 2 pi, this is 6 pi, this would be 8 pi. That is the period, 8 pi. Now, that is going to find us our k value. It's not the k value. This is not something that's going to get plugged into this equation. Remember, the period is 2 pi over k. And in this case, our period, or this formula, is equal to 8 pi. So now I just need to solve this for k. So I'm going to cross multiply. I'm going to move the k over here. So that's going to be 2 pi equals 8 pi k. And then I'm going to divide by that 8 pi that's in front of my k. So if I divide everything by 8 pi, this cancels, and it would leave me with 1/4. So k equals 1/4. So that's the k value. So if I take this equation, this is a sine graph, and I plug in the 4, and in this case the 1/4, there is no vertical shift to plug in, I'm done. Y equals 4 sine of 1/4 x, and that is the equation that is the graph of. Okay? Let's look at the next one. So, first thing, what function is this? You're always going to ask yourself this. Well, if I look at the y-axis, this graph, here's its starting point. It's starting at a low point. So that's what a cosine graph does. It either starts at the high point and then ends at the high point, or it could start at the low point if it's been flipped, which we'll talk about in a second. Okay, but first things first, this is a cosine graph. What's the vertical shift? Again, this graph goes down to here, it goes up to here. This says 5 halves. Okay, so this is 5 halves, this is 5 halves, so what's that, like 2.5? Okay, they're the same, so there is no vertical shift. Again, our graph is going, this is the middle of our graph. The middle of the graph, the midline, and the x-axis are the same. So there's been no vertical shift. What's the amplitude? Well, this graph starts at -5 halves. So the amplitude, the actual amplitude is 5 halves. Okay, 5 halves. But this has been flipped. Okay, a normal cosine graph has been flipped upside down. So there is going to be a negative out front when it comes to writing our equation. But again, technically the amplitude is the height, which would be just the 5/2. Okay, now what's the period? Again, you need to know the width of the graph. One cycle. If this is where the graph starts, at this low point, then one cosine graph will finish at this low point. So that's it. So what is this? That's 2. It's just the number 2. All right, so that's the period, 2. But the formula for period is 2 pi over k, and that formula, in this case, is equal to 2. So we just need to solve. So we're going to cross multiply. That'll give us 2 pi equals 2k, which you probably will see these 2's are going to cancel each other. So k is equal to pi. Okay, so that's it. So we're going to take our normal equation, y equals, we're going to plug in the amplitude, negative 5/2. We're going to type in the function, cosine, and then we're going to plug in our k value, which is pi, pi x. That's it. That is the equation that is the formula of. Okay? All right, last one on this page. So, how about this one? So first off, what are we dealing with? Well, we're obviously dealing with a graph that's been shifted. Okay, so that's the first thing let's take a look at. Here is where the graph crosses the y-axis. So this is my middle, my midline, the middle of the graph. So if you were to pretend that this was the x-axis, notice what our graph does. Our graph goes through the middle, and then it goes down, and then it goes back up, and then it goes down again. It's right here. So, first off, what kind of graph is this? This is a sine graph. It starts in the middle. It doesn't start at the high point, doesn't start at the low point. It starts in the middle. So this is a sine graph. Vertical shift. Well, sine graph usually goes through the x-axis. So since it's going through this point, which this is negative 1/2, this is negative 3/2, so this is negative 1. That's our vertical shift. So this graph is going down 1. So that's going to be at the very end of our equation. That's our h value. Okay? What is the amplitude? Well, this graph goes from negative 1 down to negative 1.5. So that's the amplitude, a half. Again, this goes down first. So this normal sine graph has been flipped upside down. So it is going to have a negative when we go to write the equation. So if you want to write it there, that's fine, but still understand that the amplitude is a positive value, but this one's been flipped. Okay, what's the period? Well, again, that's this overall width from here to here. Don't look at the end of the graph. This is nothing. This is the start of a second cycle. We don't need that. We just need to know where the graph starts, where it finishes, and that is at 4 pi over 3. 4 pi over 3. So I'm going to go over to the side here. I'm going to set 4 pi over 3 equal to our formula, which is 2 pi over k. All right, so I've got a fraction equals a fraction. First thing I'm going to do is I'm going to cross multiply. I'm going to take this k times the 4 pi k. I'm going to take 3 times 2 pi, which is going to be 6 pi. All right, so let's see what's going to happen. First off, notice these pi's are going to cancel. You got a pi on both sides. And so now the only thing in front of the k is a 4. So I just need to divide everything by 4. Now, don't leave this. 6 over 4 is 3/2. So 3/2 is my k value. All right, so now I'm just going to take a normal equation. So y equals a sine kx plus h, and I'm going to plug these values in that we found. Okay, so the first thing we know we plug in is the amplitude, negative 1/2. Y equals negative 1/2. Then we plug in the function. In this case, it was a sine graph. K, what do we find? 3/2. All right, so we're just going to put a 3/2 in front of the x. I usually put parentheses and close that off because now we're going to put plus something. Well, in this case, we're actually going to put minus something, minus 1. And that's our h value. And that's it. So you're just going to look at the graph and piece by piece figure out the different parts and what's going on with the graph, and then we're going to put all that together into the equation. Okay? All right, last thing we're going to talk about today. When we've graphed equations, we have taken them and we've stretched them vertically. That's the amplitude. We've talked about how you can shift them vertically, so take the whole graph and shift it up or shift it down. We've actually talked about stretching them horizontally. That's the period. You don't notice that as much because we just do it by changing the way we label the x-axis, so they all kind of look the same, no matter how wide the graph is supposed to look. But the one thing we haven't done is we haven't done what's called like a horizontal shift, okay? And that has its own name when it comes to sine and cosine graphs. It's called the phase shift, okay? So that's the last piece of the puzzle we're going to put today. So phase shift is going to add one thing to our equation, that little minus c right there. So we already know the a, we already know the k, we already know the h, so those are not going to change. C, this c is called the frequency. That's not something we're going to talk a whole lot about. What you need to know is this, how to find the phase shift. So the phase shift is a formula. It's the c value. Now notice there's no minus here. That minus is part of the equation. So if you see a minus, like a -2, then that c is just a plain 2. But if you see a +2, remember, there's supposed to be a minus there. So it would be, if you see a plus, it's because it's really a minus negative, and they've let the two negatives cancel each other out. Okay? So the phase shift is our c value divided by our k value. So just like there's like a little mini formula to find k, there's going to be a little mini formula to find the phase shift. Okay? So let me show you how to do one of these. It's going to add one little tweak to how we do our graphs, but I don't think you're going to have a whole lot of trouble with it. So look at the first one. So I've got 3 sine 2x minus pi. All right, so what do I know here? I know it's a sine graph. So sine graphs look like that. Okay, I'm just going to be thinking about that. I know the amplitude is 3. I know my k value, well, so remember, or the period, excuse me, the period is 2 pi over k. Well, the k is a 2, so it's going to be 2 pi over 2, so it's going to be pi. So that's the period, pi. And then I know that this graph is going to have a phase shift of, well, so remember, that minus is part of the formula. So it's the opposite of what you're looking at. So it's just the positive pi value, not the minus pi. So it's pi over 2. Pi over 2. So here's what you're going to do. Just make a normal graph. Now we're just going to do one cycle. So I'm going to go out to pi. That's what I need my period to be, is 1 pi. So I'm just ignore the phase shift for a second. So that's a pi. That means that's pi over 2. That means that's pi over 4, and that's like 3 pi over 4. Okay? That's important. Amplitude is up 3 and down 3. Okay, so that's 3 and that's negative 3. Now, the x-axis is very important. It's a normal x-axis. We went out to pi, we cut it in half, we cut it into quarters. But our phase shift is pi over 2. So our normal sine graph is going to shift over here to pi over 2. It's going to shift 2 of these increments, our little intervals. So instead of starting at the origin, we're going to start here. And if I needed to shift my starting point by 2 little increments or intervals, that means the end of my graph is also going to have to stretch out. So I'm going to take my normal graph and I'm just going to add 2 more increments. That's where my graph's going to end. My graph is going to start here. It's going to go up to the high point. It's going to come back down to the x-axis. It's going to go down to the low point, and then it's going to come back up to the x-axis. So this is my graph. Only draw one cycle, because sometimes when you draw a second cycle, it's hard to tell where did you actually start. Did you shift it to the right like you're supposed to? Did you accidentally shift it to the left? So we're just going to draw one cycle on these so that I can clearly see the shift. Okay? So that's it. So this is pi over 2. This is pi. This would be like 3 pi over 2. That's where this graph starts and ends. Okay? Take a look at the next one. I've got a cosine graph. So again, at the very beginning, I'm thinking this. That's cosine. So what do I know about this cosine graph? I know it has an amplitude of 2. The period is going to be 2 pi over k, but the k is a 1, so it's just going to be 2 pi. So right now you could draw our graph, our like x and y axis. Our graph is going to go out to 2 pi. That would be 1 pi, and that'd be pi over 2, and that'd be 3 pi over 2. Okay, if that's 2 pi, that's 1 pi, that's pi over 2, and that's 3 pi over 2. Now, this graph has a phase shift. Oh, I guess I could also do the amplitude up 2 and down 2. Phase shift, remember, it's the opposite of what you're looking at divided by the number in front of the x. But in this case, it's just a 1. So it's just going to be negative pi over 2. So that's our phase shift. So first off, what is pi over 2? With our graph that we made, what is pi over 2? Well, that's pi, that'd be pi over 2. So pi over 2 is one of these little increments, these little intervals that we've divided our x-axis into. But we want to shift left. We want to go in the negative direction. Okay? So I'm just going to come over here. I'm going to go left. That's what that would be. That's negative pi over 2. If that's positive pi over 2, that's negative pi over 2. And that's where our graph's going to start. This is a cosine graph, so we're going to start at the high point. Once you have that starting point, then it's just move to your right and do what a normal cosine graph does. It comes down to the x-axis. It goes down to its low point. It comes back up to the x-axis, and then back up to its high point. This is one cycle of that graph. Okay? Has a domain, you know, I didn't ask you about like domain and range, but again, domain, all real numbers. The range goes from 2 to negative 2, something you can clearly see once you've got the graph. Okay? All right. Let's take a look at the next one. So, cosine, that negative is jumping out at me. Okay? So this is a cosine, but it's going to look like that. Okay? So I like to kind of think about these before I start graphing them. This has an amplitude of 3, but it's flipped. It has a period. So what's the period? 2 pi divided by k, which is negative 4. So 2 pi, let me go ahead and just write that. 2 pi over negative 4. The 2 and the 4 will reduce, and you'll get negative pi over 2. That's our period, negative pi over 2. So that means this graph goes the other way. Okay? It goes this way. So this, if this is where the graph starts, this is where it would end at negative pi over 2. So that'd be negative pi over 4. And then I'm going to cut those into quarters. All right, that's okay. So this is kind of a, this kind of is going to have a vertical flip, but it's also got a horizontal flip. That's what's going on there. That's a horizontal flip. It just changes the period, makes the period negative. Okay, so just draw it in a negative. We're going to draw it from right to left instead of left to right. All right. Now, it's got a phase shift as well. So let's take a look at that. Remember, it's the opposite of this divided by this. So negative pi over negative 4. So that's going to be pi over 4. So our phase shift is positive pi over 4. So let's figure out what the heck that means as far as our x-axis goes. Here's negative pi over 4. It's 2 increments to the left. So I just need to go 2 increments to the right, and that's pi over 4. So that's where this graph's going to start. Remember, I said it's going to go from right to left, but this is the rightmost edge of our graph. Now remember what we're drawing. We're drawing a cosine that has a negative amplitude. So it's going to start, so 1, 2, 3, up, 1, 2, 3, down. This is where the graph's going to start, right there where my 4 is. Okay, so pi over 4, down to negative 3, that's where my point's got to be. I'm just going to make it great big, and I'm just going to wipe out that pi over 4. All right? Then just draw a cosine graph. What's cosine do? It goes up. Then it goes up to its high point, which is, oops, ooh. You see what I did? I skipped over my increment here. So ignore that for a second. Here's what I should have done. I should have went up to the first increment. You probably did it right. You weren't even paying attention to me. Then you go up to your high point, then down low, and then down to your low point. And you get this really tall, skinny looking graph. And again, it's skinny just because of the way I drew it. If you made your graph bigger, it may not look as skinny as mine. So that's why it's important that we label our x-axis so that we can see that we're all drawing the same thing, even if our graphs don't look the same. Okay? Tell you what, why don't you pause the video, try D, and then play the video and see if it's right. Okay? So hit pause. All right, so I'm going to go and take a look at from this point. So I found all my information, the amplitude, period, and phase shift. Okay? And then I went ahead and made my x and my y axis. I went ahead and labeled those. So that now I can kind of take a look at, so the period was pi over 2. So there's how far we went. But the phase shift is negative 3 pi over 4. So negative 3/4. So first off, what does 1/4 look like? Here's 1/4. So if I go to the left, that'd be negative 1/4. I had to go 2 increments. Okay? But then I'd have to go another 2 increments. That'd be negative 2/4, which we would normally write as pi over 2, not 2/4. And I need to go further. Another 2 increments. That's negative 3 pi over 4. So that is where this graph is supposed to start. Okay, that's okay. Once you get your starting point, then it's just a matter of following the x-axis and putting all your points in. This is a cosine graph that's going to start at its high point. So I'm going to come over here to this negative 3 pi over 4. I'm going to go up 2 to the high point. And now I'm going to come down to the x-axis. I'm going to go down to my low point, up to my x-axis, up to my high point. That is my graph. That's it. That's the first cycle, is way over there. Okay? Last thing we're going to look at real quick is what if I gave you information about a graph and then asked you to graph it? So first off, I'm going to write down y equals, now these are all sine graphs. I'm not going to try to trick you with that. So sine graph, so a sine kx minus c plus h. Notice on the graphs we did, I didn't do a vertical shift. I could have, okay, and so we would have just went up 2 or down 2, and we would have drawn that midline and just based everything off of that, okay? This problem as well does not have a vertical shift, but if I did, you would just put a plus 2 on the end of the equation, okay? Amplitude is 2. All right, y equals 2 sine of, well, I need k and I need c. So k comes from the period. So I'm going to take the period of pi, I'm going to set it equal to the formula for period, and I'm going to solve for k. I'm going to cross multiply. K pi equals 2 pi. The pi's will cancel. K equals 2. All right, 2x. Now I just got to figure out what my c value is. Now remember, the formula for phase shift, which in this case is a negative 2, is itself a formula. It's c over k. But I know k. I found that in the last step. So c, the thing that I don't know, over k, which I do know. It's 2. And a simple little cross multiplying gives me a negative 4. So there you go. Minus negative 4. So plus 4. And that's the formula. Okay, so we can do that as well. We can write an equation given all this information, including this new thing we found, which is phase shift. Again, it's just a little bitty math problem you got to do to figure out what your c value is. I'm not giving you the c. Okay, that number did not get plugged in. I used that number in the formula to find c. Okay, so take a look at your worksheets, your homework, and then let me know if you have any questions. Thanks.